Everyone, September the 9th. Alright, so I have an interview in 2 days. It's a full stack. I just feel funny because I really don't have much web development experience. I have a lot of mobile app, but I start to get a bit worried. So, honestly, I think I'm gonna just tomorrow, if I have time, to go through some of the front end stuff. React, right? But maybe do some Next.js. I have a Next.js tutorial open. I just never really dive into it. Um, yeah. So basically, I want to just try a little bit and see how it looks like. So during the interview, I won't look completely like a moron, not able to answer any questions, that type of thing. So that's kind of the thinking behind all this. Um, yeah, we have to see how it goes. I've got a little bit worried. But on the other hand, I mean, I have been not having any luck interview wise. I think something wrong with my resume. I think it's probably just not standing out or whatever. Um, so I'm gonna make some changes to that. I don't really have a personal website showing off like my portfolio. I don't have it, mainly because I think GitHub is enough. You just go to my GitHub and take a look. I don't know. I don't get a very good response rate. So I don't know why, but my theory is no wow factor on my resume. People look at it like, oh, this is a generic one. I need something to grab people's eyes. So what I think I'm gonna do is I'm gonna remove all my publications. I don't think those things help me at all. And in place of that, and I already list the projects that I'm most proud of, but I'm also gonna list the technical writing that I did in the past. And in fact, I'm gonna write one more very soon. I'm gonna write one more. I guess those will get more attention. There are links, right? There are links, kind of show I have knowledge of some stuff, even though the stuff I've done this long time ago. So yeah, I guess I can try that and see if there's any change. Otherwise, it's really hard to sell myself because I'm just lazy. I don't want to build a portfolio site. It's like, what's the point? If you need me to build it, I will do it. It's just a tutorial away, and it's not the first time that I have to deal with something new. Yeah, I'm not so sure, but anyway, let's deal with today's stuff. Yesterday was bad. Yesterday was so bad. I guess I don't know. Yesterday, I solved it, but okay. Let's put it this way. I solved it, but was a very bad method. Okay, and then I tried to do it in the right way, but I completely went the wrong direction. And I went back to check the actual good solution, and I realized, oh my god, it's actually quite easy. So it's a little bit frustrating. Okay, let's hope today we can change things around. All right. So most likely, yesterday was DP, so today is definitely DP. I mean, I've done this before, but I don't remember. N is only 500, so we're looking at ON squared, right? ON squared DP. So we'll see. Given n orders, each order consists in pickup and delivery services. Count all valid pickup delivery possible sequences such that delivery I is always after. Delivery is always after off. Always after pickup I. Since the answer may be large, so if it's 1, so P1, D1, 2, we have P1, D1, P2, D2. All we want to do is the P1, D1 is after P1. Very interesting. Interesting problem. So, I think, I don't know. So we could like say we put P1 first, right? If we put P1 first, all we need to, so 2 means we have 4, right? I put 4 stuff. And P1 and P2 can be, I was going to say can be any place, but technically it cannot be any place. But they are independent. right? They are independent. I got P1, like P1 and P2. Hold on, let's do it this way. The different orders are independent of each other. So I just have P1 and P2, right? And I have 4 positions. I can put P1, P2 in any of the 4 positions. It doesn't really matter, right? And it doesn't matter. But it has to be in this order, in a P1, P2 order. Which means if I do 4 choose 2, right? 4 choose 2. And then once we choose, we always assign the first as P1, D1, not P2. We choose the first as P, the second was D. So that give us, what's 4 choose 2? 4 times 3 divided by, 1 times 2? That's 4 choose 2? Yeah. 4 times 3 divided, that's 6, right? And then remaining, we have 2 remaining, right? So we pick up 2, and remaining is 2. And when you have remaining 2, there's only one way to do them, right? Only one way to, so the answer is 6. Yeah, so it's like it's a degree of freedom, right? And when you have only 2 left, there's no more choices. Okay, so 3. Right, 3. So we have 6 positions. So we can say 6 choose 2, right? 6 choose 2, we basically take 2 away, and we have 4. And times 4 choose 2. I don't know, I'm just pull this out of my hat. What's that? So that's 15 times 6, 90. Is that what we're looking at? Huh. So let's say, let's do one more. 5, n equal to 5, right? So we say 10 choose 2 times 8 choose 2 times 6 choose 2 times 4 choose 2. Right? And basically it's 10 times 9 divided by 2 times 8 times 7. Look at that. 6 times 5. Look at that. 4 times 3. So basically it's, yeah, you can actually keep going. So 2 times 1 divided by 2, right? So that's 10 factorial divided by 2 to the 1, 2, 3, 4, 5 power. So it's 2n factorial divided by 2 to the n. Okay, what do you think? I have no clue. Well, we can give it a shot. Let's do a number. Oh God, 2 times 10. Oh, it's not gonna work. 2 times. So we need a smarter way to handle this, right? I mean, each one has to be, this is a even number, right? So basically it's 5 times 9 times 4 times 7 times 3 times 5 times 2 times 3. So it will be 5, 4, 3, 2, 9, 7, 5, 3, right? So that is n equal to 5. That's what I think, n equal to 5, right? If that is n equal to 5, then what we can say, is we always go 2, 3, 4, 5, right? So 2 times all the way times to n. What's the other side? The other side is, so basically 2 plus 1, right? It's 2 plus, 1. No, that's the odd, right? So starting from 3. Actually, if I can go all the way down to 1. So we can say 1 and 1, 3, 5 to 9. So that's like 1, 2, 3, 4, n. So this is n as well. Okay. You want to give this a shot? I mean, we can try n equal to 3, n equal to 4. Okay. So we say 1, 2, 3, 4. My God, your handwriting is horrifying. 1, 2, 3, 4. 1, 2, 3, 4. Wait, let's see. So that's 4 factorial times 357. 2,520. Not sure. 2,520 is right. I hope I don't make mistake like this in interview. That'll be very embarrassing. Yeah, I think that is the result. So we just need to code it, right? We just need to code this. So how do you want to do it? I want to do 2 rounds of. So we say int res equal to 1. Okay, for int I equal to 1, I small equal to n, I plus plus, right? And I do need a j. Or can I compute the other one from this? Yeah, I think we can. 2 times minus 1, 2 times this minus 1, 2 times this minus 1, 2 times this minus 1. So what we're gonna say is res will equal to res times I. Oh, that might we need to figure out the overflow type of thing. We need a mod. Yeah, I forgot the mod. So int mod is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then we can say they might explode. So yeah, let's do that. This times I mod, right? And then this times 2 times I minus 1, and then we mod, and we'll return res. Okay, let's give us a shot. Let's go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, that should be enough. You should do a 500 as well. No, it's not right. 90. That's good. That's good. Yup, overflowed. Dirt. 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 Long. This is int. Yeah, that's int because I'm actually not sure. Is that int? What's 2 to the 31? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that is int. So if we do that, and we're just gonna return int it. Alright. That looks good. Let's throw a 500 at it. Alright, we can do this. Why you complain? Cast too long. Alright, we will cast here then. Can we cast here? Long. Then it says not necessary. Now I'm confused. Casting this too long. No, I'm not casting this too long. I'm casting this entire thing too long. Alright, let's see. Why you... Oh, that is interesting. Wait, clean up code. Oh, 2L is... Wow. I didn't know that. Did not know that. What? 1, 3, 5, 9. Each order is independent of others. Thus, for each order, the possible ways to place them among the empty spots is n choose 2, where let's use small n, where n is the number of empty spots. Thus, the first pair has n choose 2 possible ways. The second pair has n minus 2 choose 2 possible ways. The last pair has 1. So basically 2 choose 2 possible ways. Now we cannot compute all the combinatorials directly, but we can expand them and find pattern, right? And we take advantage of the pattern and perform multiplication to find the answer. Note that the result has to be long to avoid overflow during the computation. Call it ON. Not sure what time it's gonna run. Okay. So last time it was, yeah, it's 0. Bless you. Alright, we gotta, let's throw us an easy ball today. Yep. Yeah, but Python, you don't have to deal with overflow. That's it's basically the only difference. Okay, let's put it here. Alright, let's back to this one. So I need to copy and paste this because this is the right solution. Now we're gonna see other people's solution. I use arrays. What other people do? Promise arrays. Timeout within promise. Yeah, arrays is the easiest way to solve this, I think. Original promise. Timeout promise. Yeah. Oh, yeah, this is actually better. Yeah, people don't know. I think it's clear automatically. Clear timeout. Yeah, I think it's very straightforward. It's a race. I mean, I thought about this when I was really frustrated because I couldn't solve this problem. I was just thinking, can I run two in parallel? Can I run two in parallel? And the answer is, we can. All right, hold on. All right, I'm back. So that's another one I want to look. This is the one I want to take a look. Use promise and call. If callback is returned, so if this one finishes, but oh, wait, hold on, are you saying we call setTimeout, it doesn't hang? Clear. They clear the timeout. Wait, what does this mean? So when you call setTimeout, does it hang? Right? I think they come down to this. Does it hang? Yeah, as yesterday I forgot how to sort. Does setTimeout hang block? Oh, it It's non-blocking. Oh my god. Wait, hold on. Go to console. I gotta try it. I cannot copy and paste your code. Dirt. Okay. And we just set timeout. A console.log bar 3000 and console.log foobar. Show me. Oh my, it's non-blocking. I think that's probably one of the reasons why I have all the bugs in my code, because I thought it's blocking. No way. Wait, this is interesting. Uh-huh. It's non-blocking. It will execute only after all. It will execute only after all the statements outside it have been executed, as opposed to blocking code that blocks the further execution. It's a concurrency. It's like that burger. It's like async IO. It's async, right? Basically, it says when you call setTimeout, you have a piece of code that needs to be executed, but you have to wait on it. And while you're waiting on it, then JavaScript executes all the other code until something else needs to wait, or until it executes everything, and then it comes back to this. JavaScript is single-threaded as well. Oh, there's no thread. There's only concurrency. Registers the callback function, yes, and it waits for the specified time. Then it is moved to the callback queue and waits for the call stack to be empty. Hold on. So it registers the function, waits for this time, but it doesn't mean it will execute after this time. What it means is after this time, it gets moved to the callback queue and waits for the call stack to be empty. The moment it gets empty and there's no other function waiting, the callback function moves from the queue to the call stack and it gets executed. Oh, wow. You see, that's the benefit of going through all these problems, and deeper understanding of this. I'm pretty sure when I was reading this book, I'm pretty sure it's explained. I just forgot. Alright, so web API, we set timeout, register function, and it waits for the specific time. When the time is over, gets pushed to callback queue. So it waits here until the stack is empty, and then it gets pushed into the stack. And then we have event loop constantly running to check if the stack is empty. If it is empty, you can actually build a simulator of this. Yep. So we registered, and then we wait for 3 seconds. And then we'll get pushed here. And this event loop, because this will keep going. Every time we go, you will just wait, right? But let's see. When the statement is executed, it gets moved from the call stack. And this one does all the work, because the next call stack is adios. So it will call the adios, and then this gets moved. So we get the adios first, then do this. Wow, a million line of code after timeout. First, all the blocking code has to be completed, and then it will execute. It's not the time for function execution, but actually the time after which moves the callback queue. Wow, it's a great explanation. Yep, well explained. I have been wrongly assumed that setTimeout is blocking for years. Wow. So now this is very straightforward. This is a great solution. It's non-blocking. Ha! What you wanna know? You don't know. It's non-blocking. God, man. Oh, now we don't need this. Set timeout is non-blocking. So we can call setTimeout. Reject. No, it's okay. Okay, we set timeout. Async. Throw. Time limit exceeded. T. Timeout ID equal to this. Right. And then we call Oh, but if it's throw, how do you prevent it from? Yeah, hold on. I actually don't know. How do you prevent it from? Oh, you can clear it out first. Holy crap! Wow, I'm learning things left and right. Jeez. So I can clear timeout first. Then I throw. Then I'll return fn args. Because this is async, right? And now I executed. This is waiting as well. So both are waiting. So whoever, yeah, so this push it to wait. And this push it to wait as well. And whoever gets finished waiting first gets pushed into the callback queue. And because there's nothing, it's basically everything's end where there's nothing in the call stack. So whoever finished first gets pushed to the call stack. Then it will call. Yep. Dear me. Hold on. I need to copy this. Hold on. Let me get a cat out. All right, let's try. All right, is this correct? Wait, what? What did you do? I don't know. I think this code might not be correct. Maybe I don't do anything here. I just throw. Nope. Huh. Can you not throw inside this function? I guess that's not the way to go. Okay, so we return new promise, resolve, reject. Timeout. Then we don't have this throw, we just call it reject. And then we call fn args. But we need to resolve dot then wait. I saw this syntax. I'm just copying the syntax. I'm not 100% sure. Yeah, this is correct. Hold on, let's take a look again. Dot then resolve. Dot then. What's this syntax? Dot promise. You get a value. Oh, unfulfilled, unrejected. Yeah, so we return a promise, and this is the callback that will resolve the callback if it's reject. Resolve to some value and then reject some value, right? Wow, this is a great solution. Yeah, I guess the other one you just cannot throw inside. Have to reject. Good. Yeah, I didn't know. Set timeout is non-blocking. Good to know. Okay, so move on. Nested array generator. Given a multi-dimensional array of integer, return a generator object which yields. Oh, yields. I don't know. What the hell is yield? JavaScript has yield in the same order as in-order traversal over each array from left to right, yielding any integers it encounters, or applying in-order traversal to any array it encounters. So in here, we go 613. In-order traversal generator, .next. Alright, so the first thing you need to do is, what the hell is a generator? Returned by a generator function, and it conforms to both the iterable and iterator protocol. It's a subclass, so function. So when you put a star, it becomes a generator. Yield does this. It can do the off. Okay, constructor. Generator function. .next .value. A hidden object, which is the prototype object shared by all objects created by generator. It's often stylized as generator the prototype to make it look like a class, but it should be more appropriate called generator function. Corresponds to the generator constructor. A hidden object, which is the prototype shared by all objects. I didn't quite understand this one, but it's okay. I just keep reading. .next. .return. .throw. Do you have example of dot return? The current suspended position, which finishes the generator and allows the generator to perform any cleanup tasks when combined with a try finally block. Example, generator 3. If I call this dot next and I say return full or value full and then done is true, and then you keep calling it, will give you different stuff. Let's call a generator that is already in complete state. The generator remaining, if no arguments is the value of the return option will be undefined. If an argument is provided, it will become the value of this, unless yield expression is wrapped in a finally, try finally block. Alright, this is what I want to see. So your call return actually can tell the generator what the next one is. So if I do this, try yield, finally, yield cleanup. Okay, so we get this, dot next, that's cool. Dot return, early return, suspended. And we got 2, now we're inside. Then we do this. Values cleanup. So I break out. Yeah, you do return, you will break out whatever is being yielded, but if it's in a try finally block, it will go to this. What's try finally? Completion is preserved. Ooh, hold a second. False, false. Execution suspended. So execution suspended. So return value is this. But done is false. Oh. So it's just being suspended. And you can call it again. Then you'll return. Oh, you suspended it, so it goes directly to pointing here. Then you call it again, it calls this. Then the value of the final can also become the value of the result. Interesting. The next question, what's this try, catch, and finally? Let me try this. Try, catch, and finally call out to run regardless of the result. So basically this means if we have error, we'll skip it. No, it is regardless of the try result. So this will always execute. Okay, so it will throw and it will catch, but it will always Yeah, it'll catch the error. Actually, that's fun. Right, you see that? This one will always execute. It doesn't really matter if you... Nice. Okay. Now we go back here. So this is definition with a star is a definition of a generator. Perfect. Okay. Now we just need to know how to yield from this thing. Array. So we can say yield if it is an array. Right? So I think I will do something like this. How to check if it's an array? Full instance of yeah. But yeah, I think I'll use instance of. Okay, here's what I think. If array instance of array, then we will yield in order traversal. No, that's not right. It is an array. Okay, so the input is going to be an array. We can say for const a of array if a is, then we do a, right? Else yield a. Okay. What do you think? So it will work? That was funny. Dude, that was funny. That was very funny. Why it got 999? What? Alright. Oh my. Let's just take a look. Console the log array. What the hell happened? The hell? Huh? That is weird. Yeah, this is what I expect. A instance of array. Is that one? True, and true. So that's true. Then we will yield our in-order traversal, which is A. Oh, but this is... Ooh. So I'm in-order traversal. I go inside that. I call that function again, which shall give me that is interesting. Will yield that value. I guess you will yield whatever is yield. Hold on. So I need to look into JavaScript generator recursion. I always have trouble with it. In Python it's the same. I don't think recursive generator. Does it have any? Oh yeah, this is exactly what I want to do. Oh, of course, you did not call yourself recursively. Oh. Yes, but you wanted the iterated value of that to be yielded. If you want to yield recursively, you need to yield star. You need to yield star. Oh, I guess we also have this empty. Okay, let's try this. Oh, I think this one's right. Yeah, I knew it. It's gotta be some syntax error. Yield star. Yield star. I think that's the only thing we need to change. Yield star. So recursive generator in JavaScript requires yield star reference. What about Python? I forgot. What's Python? Of course it can. Oh, yield from. Yeah, Python requires yield from. So yield from, this is yield star. Okay. Yeah, it's perfectly fine. Recursive generator. Array dot is array. Yield star. Okay, here's another question. Which one is the best way to check if it's an array? Yeah, these are not what I'm looking for. Hold on. So JavaScript, right? What is the best way to check what array? Use isArray function. Slow is the fastest. I just got another rejection. Jesus. Oh, I have to do all the I guess I'll just do is instance of. Alright, anyway, I'll just keep is instance of. That's fine. Alright, that will be it for today. I don't want to do another one. Let's just call it. I will see you guys tomorrow. Adios.